Okay, so here I want to put together as the different numbers into different categories. So the way I set this up is, let's start with the most basic type of number, which would be whole numbers, and those include the ones that you would count 1, 2, 3, on up to whatever number you can count to. So those are whole numbers. Then we go to integers. Integers are the whole numbers and their opposites and zero. So all of these numbers are included in this one. So 1, 2, and 3 are also integers. Okay, then go to another level out, and we have the rational numbers. So the rational numbers are all the numbers that can be expressed as a fraction. Those include integers and whole numbers, right? You can express 6 as 6 divided by 1. So a whole number is also a rational number. But the new ones that are added are the ones that cannot be expressed as integers and whole numbers. So these fractions here, like 5, 6, and negative 1/2. Then the level out that we go to is irrational numbers. So irrational numbers include square root of 2, square root of 3, phi that we saw, and also pi and e, which we call are kind of special types of irrational numbers that we call transcendental numbers. And also I put on there tau. Tau is just 2 pi, and some people like to use tau, some people like to use pi. I prefer eta, which is pi divided by 2. So anyway, all of those fit into transcendental numbers. So these are all these together are all real numbers, and you can find these on the number line in their different locations. So you can find the whole numbers going this direction. You can find the integers going over here. You can find the rational numbers between whole numbers, and irrational numbers also fit on there. So like pi was 3.14 around there. So this is an approximation of pi in that location. If you want to go to 2 dimensions, x and y, then you go into vectors, and you can have an x value and a y value. Those are actually coordinates, but vectors would be in the direction of x and y. Matrices are whole groups of numbers, and you can have things like this in math. I don't know, 3, 2, 1. So this is a matrices where you throw a whole bunch of numbers into a list, and then the big picture is sets, that not just numbers, but also sets of things like different subjects in school or different colors. That kind of covers everything that is possible. There is another type of number system that we aren't really getting into, but I'll just show you for clarity, just to be complete. And there are the imaginary numbers, which are the square root of -1. So these are not found on this number line, but there are things that we can do with imaginary numbers that are interesting, and if you set the rules and then follow those rules to their conclusion, they end up with pretty amazing results. And then if you have a combination of imaginary numbers and real numbers together, if you have like something like this, 3 times this number I, which is I is just the square root of -1, plus 4, this has an imaginary part and a real part. But anyway, you'll get into that in Algebra 2, and there are neat things that you can do with that type of number. But what we're going to do is just categorize our numbers. Where do they fit? What is the, in the simplest form, where do they fit in this scheme of things? So like the square root of 16, where does that fit? Well, this can be simplified, right? This can be simplified into 4, which would be a whole number. Okay, where does 3 square root of 2 over 2, where does that fit? Well, I actually cannot divide this 2, so this is actually as simple as it gets, and it's 3 times this. So I could write it like this, 3 halves times the square root of 2, so this is an irrational number times rational number, and it's just an irrational number. How about my number eta? Eta is the same thing as pi over 2. Well, pi is a transcendental number divided by a whole number. It doesn't change that it's transcendental, so this would be transcendental. Okay, so that's an example of categorizing those numbers.